Hello, in today's video, I'll be solving questions on A-level reaction kinetics from May-June 2024, paper 4-1. Question 5, A. In aqueous solution, persulfate ions S2O82- react with iodide ions as shown in reaction 1. S2O82- plus 2I- giving 2SO4 2- plus I2. The rate of reaction 1 is investigated. A sample of S2O82- is mixed with a large excess of iodide ions of known concentration. The graph in Fig 5.1 shows the results obtained. So this is the graph in Fig 5.1 where concentration of S2O82- is plotted against time in minutes. I. Use Fig 5.1 to determine the initial rate of reaction 1. Show your working. We know that rate is equal to change in concentration over change in time. And so this will be change in concentration of S2O82- divided by the change in time. And when you have been asked to calculate initial rate of a reaction where a graph has been given, it means that you have to draw a tangent to the curve at t equals 0, starting from the initial concentration. So drawing this tangent, we use a ruler and then we draw the line under this curve and then we trace it till we get to the time axis. This means that my t1 equals 0 and my t2 equals 32.5, and also my initial concentration, so C1 is equal to 0.8, and my final concentration, which is C2, equals 0. Therefore, the initial rate is equal to 0.8 mole per decimeter cube divided by 32.5 minutes. And this gives us 0.02 mole per decimeter cube per minute. The rate for reaction 1 is rate is equal to K, which is the rate constant, times the concentration of S2O82- times the concentration of I-. Suggests why a large excess of iodide ions allows the rate constant to be determined from the half-life in this investigation. We know that half-life, which is T half, is equal to ln 2 over K, or 0.693 over K. So it means that our rate constant can be 0.693 over T half. Now we are using this equation because the order of reaction with respect to I- is 1, which is first order with respect to I-. This equation is only used for first order reactions. We can use this equation to determine K because the concentration of iodide ions is not changing. We are only using a lot of this iodide ion solution. It doesn't mean that the concentration is changing. If the concentration changes, it means that our half-life will also be changing. And so since the concentration in this case is the same, it means our half-life is the same. And so it makes determination of K or calculation of K very, very easy. And so you have to say that concentration of I- is constant. And so once it is constant, we can easily determine the K. B. The reaction of persulfate ions S2O82- with iodide ions is catalyzed by Fe2 plus ions. Write two equations to show how Fe2 plus catalyzes reaction 1. So we were told that the reaction is occurring between S2O82- ions plus iodide ions. And this reaction gives us, it's a redox reaction that gives us 2SO4 2 minus plus I2. And so to balance that, we put 2 here. Now, you can see that the reactants are both negative ions. And anytime you are adding negative to negative, there will be a loss of repulsion. It means that the rate of this reaction is going to be very, very slow. So in order to speed up the rate of this reaction, we use a catalyst. And the catalyst helps to speed up the rate of this reaction. The catalyst in this case is Fe2 plus. So we were told that it catalyzes reaction 1. So Fe2 plus S2O8 2 minus ions. This is an oxidizing agent. And so we can see that it is undergoing reduction in this equation. So which means that we can use this one to actually oxidize the Fe2 plus to Fe3 plus and not use I minus in reaction 1, because there is no way we can reduce Fe2 plus with I minus. It is rather easy to oxidize the Fe2 plus to Fe3 plus. So we get Fe3 plus SO4 2 minus and 2 moles of that. If we put 2 moles here, 2 moles here in order to balance the charges, we can see that at the Fe2 plus side, we have 4 positive charges here and then negative 2 charges here. When you add the 2 together, you get plus 2. At the product side, we have positive 6, and then for this, we have minus 4. When you add the 2 together, you get plus 2. It means the charges are balanced in both sides of the equation. In this first equation, we have been able to get our SO4 2 minus, which we can see at the product side. So right now we need I2, which means that we now have to oxidize the I minus. And we can do that by using the oxidized form of the Fe2 plus, which is Fe3 plus, to actually oxidize the I minus. So we have Fe3 plus I minus, giving us Fe2 plus I2. And then once it's I2 here, we have to put 2 here. And in order to balance the charges, we put 2 here and put 2 there. You can see that in this second equation, we have generated our catalyst pack. And that is what any reaction that involves catalysis does. So once a catalyst is used, the catalyst must be generated back, because a catalyst only speeds up the rate of a reaction without being used up. C. Describe the effect of an increase in temperature on the rate constant and the rate of reaction 1. We can see that in reaction 1, the rate of reaction is directly proportional to the rate constant K. And we also know that an increase in temperature increases or speeds up the rate of a reaction. And once the rate of a reaction is increasing, we can see that the rate constant will also increase, as there is a direct relationship or proportionality between the rate and the K. So we can say that both rates and rate constants increases. D. In aqueous solution, thiosulfate ions S2O3 2 minus react with hydrogen ions as shown in reaction 2. S2O3 2 minus plus 2H plus giving SO2 plus S plus H2O. The rate of reaction is first order with respect to S2O3 2 minus and zero order with respect to H plus under certain conditions. The rate constant K for this reaction is 1.58 times 10 power minus 2 per second. Calculate the half-life T half for reaction 2. And so T half is equal to ln 2, which is 0.693 over K. And since we know our K, it's just a matter of substituting the K into this equation. So we have 0.693 over 1.58 times 10 exponent negative 2 per second. This gives us 43.9 seconds. E, the compound nitrosyl bromide, NOBr, can be formed as shown in reaction 3. 2NO gas plus Br2 gas giving 2NO Br gas. The rate is first order with respect to the concentration of NO and first order with respect to the concentration of Br2. The reaction mechanism has two steps. So just equations for the two steps of this mechanism. State which is the rate determining step. When you have a question like this, and you have two reactants, the first thing to do is to add the two reactants together to get an intermediate. So you have NO plus Br2, and when you add these two, you get NOBr2, and this is an intermediate. Intermediates are used up in subsequent steps to give a product. And we can also see that from the starting reaction, there are two moles of NO, but so far we have used only one mole. So that means we can use the second mole of NO plus the intermediates NOBr2 to give a product, and our product is going to be NO2Br2. However, in the equation, the reaction equation, we are seeing NOBr and not NO2Br2. The NO2Br2 can actually be written as 2NOBr, and since this is what we are seeing in the reaction equation, it means that over here, instead of writing NO2Br2, we can write 2NOBr. The rate determining step is the reaction step where the order of reactions are equal to the stoichiometric amount of the reactant. The order of reaction with respect to NO and Br2 are both first order. It means that in one of the steps, we are supposed to see that the stoichiometric amount of NO and Br2 are 1 and 1. And so we can see that in this first equation, we are seeing both NO and Br2. The stoichiometric amount of this NO is 1. The stoichiometric amount of Br2 is also 1 in this equation. And so it means that step 1 is our rate determining step. Step 2 cannot be the rate determining step because in the question, we have not seen NOBr2. But the question has already told us the reactant we should be seeing in the rate determining step, which are NO and Br2. Thank you for watching. See you again in the next tutorial. Please subscribe to this channel.